Welcome everybody to our bauma talk. For the first time, bauma, in cooperation with WDMA, is offering a series of webinars conducting to bauma in October. In the bauma talk, industry experts will have a look on the key topics of this year's bauma edition. I'm looking forward to share this experience with you. My name is Christoph Danner and I'm working for the Mechanical Engineering Federation WDMA. Together with our member companies, we are facing the challenges of our industries. Today, the mining industry will be in our focus. Our webinar aims to show the vital importance of mining for a low-carbon economy and how this can be done in a responsible way. State-of-the-art technology helps to face challenging conditions. Under the term of Mining 4.0, different stakeholders are developing solutions to be able to face manifold challenges. Today we will have with us representatives from mining companies, the supplier industry and the academia. From these perspectives we will explore with you how reliable, efficient and sustainable mining is possible. A low-carbon economy is impossible without extracting the raw materials we need for e-mobility and other decarbonizing technologies. So, future mining must be sustainable and, at the same time, supply the raw materials in order to transform our economies. Somebody who is working on this is Professor Elisabeth Clausen. She is director of the Institute for Advanced Mining Technologies in Aachen at the university. Welcome, Elisabeth.
Hello, Christoph, thanks a lot for the kind introduction, and it's my pleasure for being here today with you.
Elisabeth, the floor is yours. Your presentation about a low-carbon economy.
Yeah, so it's my pleasure for being here today, as already said, and to share with you my thoughts on the human-centered, climate-smart mine. When we talk about mining and when we have a look at mining, mining has always been a key driver and enabler for economic growth and welfare. In earlier times, even entire decades were named after raw materials, such as the Stone Age. And also nowadays, raw materials and the production of raw materials is indispensable for economic growth and welfare. Even more, a broad range of metals and minerals is required for achieving the transition towards greener and carbon-free economies, as well as for the development of future high-tech applications. Illustrated here at the sketch by the so-called critical raw materials for Europe, which has been defined in 2020 by the European Commission. Mining as an industry plays a key role for sustainable development by, as already said, enabling the transition towards a low-carbon society. Modern technologies require significant amounts and increasing variety of minerals and metals that cannot be produced through recycling, but have to be mined. Often mining is perceived like this little block here as dark, dirty, dusty, and dangerous as an old economy, even though always the mining industry has been innovative. And still nowadays, mining operations are standing for a high-tech industry which is sustainable, efficient, and reliable. But how does the mine of the future look like? The sustainable, efficient, and reliable mine of the future implies a vision of a digitally connected, autonomous, and low-carbon emission mine. However, the mine of the future is not only digitally connected, but also flexible and selective, forward-oriented, and dynamically adaptable, as well as robust and reliable. The mine of the future is autonomous and carbon neutral. Current technological trends can be seen in the three key trends: automation, digitalization, and electrification. And therefore, key technological developments needs to cover the whole data information value chain, from ruggedized sensors and communication technologies to IoT platforms and sophisticated data analytics to generate valuable information out of these data for various applications. Represented by the bubbles here, you can see some of the core themes in which we are developing at the Institute for Advanced Mining Technologies novel solutions. And what we also see here is our core themes, what we call the so-called technological backbone for the autonomous and green mine. What we are doing is we are developing sensor technologies and solutions for a wide range of applications in surface and underground mining for hard rock, as well as soft rock mining applications. Applications ranges from asset monitoring and diagnosis, mine design and energy management, over material characterization, localization, and autonomous underground navigation, to, on the right side here, environmental perception and robotized inspection, as well as communication technologies. Specifically for the machine-to-machine communication, for example, it's necessary to develop uniform, standardized, and manufacturer-independent data formats. What we need here is interoperability according to the IoT approach. To ensure that this succeeds in the future, together with the VDMI Mining and its member companies, we are developing the so-called companion specifications of the Open Platform Communication Unified Architecture, in short, UPC-UA, standard for the mining industry. The collaborative development of such a unified interoperability standard for mobile machines in mining alludes to the fact that there are also other non-technological challenges that need to be addressed in order to succeed in realizing the mine of the future. Technology itself is not automatically a leveler. A smart mine is also an environmentally conscious and climate-smart mine. The mine of the future is a human-centered climate-smart mine. I believe that for the development and implementation of new technologies, corporations like the already mentioned ones, they are indispensable. Realizing the vision of a sustainable mine requires not only sustained innovation moving forward, but also new forms of collaboration and collaborative innovation. The mining industry, including operators, suppliers, as well as research and academia, will benefit from building and engaging in innovation ecosystems, so specifically to help to address the suite of all the challenges we are facing. The challenges we are facing and the mining companies are facing, and indeed the society are facing in this area, are simply too huge to tackle within the scope of individual companies or partners. But also beside collaboration and collaborative innovation, it is important to educate the next generation of mining engineers and also to attract talents also from other disciplines to the sector. It's also important to set up research and innovation infrastructures for developing, testing, and demonstrating novel technologies and solutions in relevant and real environments. And this is why at our institute, the IMT, we have recently invested in building up some infrastructures that enable technological development and collaborative innovation. This includes, for example, an incubator for startups in the mining space, a learning factory that provides a hands-on learning experience, not just for students, the setup of a real-size lab in an existing quarry together with the mine operator, as well as the development of a regional innovation ecosystem. When we talk about mining, there is no doubt that digitalization, automation, and electrification represent great and important potentials for making raw materials extractions more resource efficient, sustainable, reliable, and ultimately climate neutral in the future. At the same time, however, we need to succeed in improving the awareness towards the importance of raw materials among the general public and the acceptance of mining projects. And we need to manage to attract and inspire people for the mining industry. This is what we are committed to in academia and education and research, and we really hope that we can shape the future together through strong alliances. I will be around at this year's bauma, and if you're interested in reaching out or learn more about our activities, please contact us. I'm happy to see you there. Look out.
Thank you very much, Elisabeth, for this great presentation and for your perspective on the mining industry. We have learned that mining is crucial for a future low-carbon economy being able to accomplish the Paris Climate Agreement. Furthermore, digitalization is vital to make the mining industry more sustainable. One of the most promising ways to become more innovative is technology partnership between academia and the supplier industry. Elizabeth, mining is indispensable for a low-carbon economy. How could the raw materials demand of the future look like, and how could this demand contribute to a low-carbon economy?
Yeah, so there has been a recently published study by Paul-Leuven University, and this study shows that meeting the European Union's Green Steel towards climate neutrality by 2050 will require 35 times more lithium and 76 to 26 times the amount of rare earth metals compared to Europe's current use. And these numbers, what I find, are only for Europe. Lithium and rare earths are elements that can to date not provide from recycled resources. In addition to the numbers already mentioned, Europe will also require 30% more aluminum, as well as 35% more copper, 45% more silicon, 100% more nickel, and 330% more cobalt, according to the same study already mentioned. And when we talk about these metals, all these metals are essential and crucial for producing electric vehicles and batteries, wind parks, solar and hydrogen energy technologies, as well as the grid infrastructure itself we needed to achieve for the climate neutrality. And this means when we talk about millions, or when we talk about climate neutrality, we talk also about millions or at least hundreds of thousands of tons of minerals that will be required to power the economic transition. And when we look at these numbers specifically, it becomes quite obvious that primary mineral production will remain the key for the upcoming years in order to meet the growing demand. This means also that we will need to take serious steps towards developing supply sources, for example, by opening up new mines, by securing supply sources globally, or building up or working towards a circular economy.
Okay. You state that the importance of automation and digitization in the mining industry. In what way can automation and digitization support the goal of reaching a low-carbon economy in the future? So what I'm interested in is the connection between automation and the way to a low-carbon economy. Mm-hmm.
So mining itself, as you also said, is per se an energy-intensive industry, and also it's a huge emitter of greenhouse gas emissions. And as you have mentioned, the mining industry is currently focusing on three core technologies by driving transformation and change. And these core technologies are automation, digitalization, electrification, which goes actually hand in hand and cannot see directly, let's say individually. So one of the key things is when we talk about low carbon economy is talking about electrification. But when we talk about electrification, it's not only about replacing diesel engines by electric drives. And there's also the need, or at least more or less the chance to rethink mining processes. It is likely that mining operations may move away from large plants to more smaller, more modular mining processes, or for example, so that probably also micro robots are going to extract the raw materials in a selective and minimally invasive manner. And this is one of the examples that I'm strongly convinced that the technologies in the future will be towards autonomous mining. But also when we talk about the mining process, and now, for example, the electrification, the mining operations also need to be controlled in a resource-efficient way, in a way that we use minimal energy, or that we minimize the energy consumption of the mine. And also when we talk about the electrification, it's about integrating renewables into the mine operations, so that it's not only about to adapting the mining process and the mine planning and the control and the design to the deposit conditions, but it's also to integrate the energy side. And for this, of course, we need to have high quality and useful data and information, and we can generate through digitalization, and then can control the operation the best way in terms of automation. And so in this example, you see that digitalization and electrification as well as automation go hand in hand, or in other words, needs to go hand in hand for reaching the full potential.
Okay, Elizabeth, one last question. The technological development in our sector is very often driven by cooperation between academia and the supplier industry, mainly machined and plant builders, such as the VDMA member companies. Can you light up some examples of ongoing innovation partnerships?
Yeah, I'm happy to do so. And I would like to illustrate this with three different examples. And so when we think about the AMT Institute, we traditionally have always had and still have strong industry relationships and a high application orientation. And this also means that in all or most of our projects, or nearly all our projects, we are collaborating with industry partners in joint projects, in smaller ones and larger ones, and in different forms of collaborations. And we do believe, and I strongly believe, that collaboration and partnerships are the way forward and a necessary ingredient successfully developing the technologies we need to realize the autonomous and green mine of the future. And so three examples are, one example is the so-called ScaleSense project. The ScaleSense project is a project together with the company Hermann Kraus Maschinenfabrik GmbH, which is also a member company of VDMA. And in this ScaleSense project, we are specifically focusing on the scaling process, which takes place in underground mining right after blasting, in order to remove the loose hanging rock from the roof. And yet to that, very often this process is strongly depending on the experience and on human decisions and manual work. And in the ScaleSense project now, what we're doing is we are going to develop a sensor-based system for the detection of loose rock during the scaling process. And the system will be then integrated into the scaler with the objective to assist the operator in identifying the loose rock to make the scaling process more safer and more efficient. And this is actually then the foundation of the automation of the scaling process. We at the AMT, we are in this project responsible for developing the sensor-based systems for the detection of loose rocks using a combination of long-wave infrared technology and acoustic emission technology. And the industry partner is, as already said, Hermann Kraus Maschinenfabrik GmbH, is responsible for integrating then the sensor technology into the scaler and also for developing the sensor visualization concept. So another project is then a huge consortium, is the so-called Next-Gen SIMS project. And this is one of that's a European flagship project in the mining industry, where we're developing together with several partners, mine operators, mine suppliers from Europe, carbon neutral mining pilots. And the third example is that we currently set up a regulatory sandbox, or a sandbox in the vicinity of Aachen, where we have the ability to develop and test new technologies in real environment. And this only could have been made happen due to the good collaboration of our institute with a small and medium-sized company as a mine operator in our vicinity.
Okay. Elizabeth, thank you very much for the insights. Thank you very much for the Q&A. And we're looking forward to meeting you in Munich in October. So thank you very much for being with us today. And Elizabeth Clausen will be available now in the chat. Thank you. Defining how the entire mining cycle is carried out is vital for responsible and sustainable mining. We want to talk today to a person who is working on making mining more reliable and more sustainable. Christophe Didier is working for the French Geological Survey and is chairman of the ISO TC 82 SC7 committee, an international standard for mine closure and reclamation management. Welcome, Christophe. The floor is yours.
Thank you very much, Christophe, for your kind introduction. And so, yes, the objective today is to speak about a very important approach, which is the responsible mining one, and especially how could standardization provide a support to push the best practice worldwide. So first of all, what it is, why is it such an important topic? I think one of the most important facts is that the world today has to face some very big and global transitions. Some of them, as you can see on the slide, is connected to numerical transition or especially energetic transition. We have to face some challenge to decarbonize the industry and the society by its whole. And so we need to develop some new technology to enable us to get free, a little bit more free from carbon. But this means developing new technology, and those new technologies require more and more metals. This means that, as you see on the picture, from the old technology like a mill to the one today like a wind turbine, we need much more metals in terms of number, but also of amount. And if you see on the document also, especially dealing with the development of the electrical battery, we have to face an incredibly high amount of supply in terms of lithium, for example, or cobalt, which is multiplied by several, by a large amount of you see, 60 times more lithium in the coming decades. So it will be a very large challenge. So in terms of possibility to access to these metals, there is a big also topic, which is the possibility to get the agreement from the society to get access to this metal. And as it is written on the document, mining industry is not always and not everywhere positively perceived. In some places, this is an important and operational and very active industry. In other places, especially in some countries of Europe, it has quite a bad image, and people are not very positive with the idea to reopen mines. So there is a lot of challenge to face in order to explain and to get people invest in the process. So that's the big challenge of social license to operate. We need to improve the consultation and the involvement of stakeholders in order to be able to get agreements. And for this, we need to develop some shared references, some shared labels or standards in order to be sure that the best practice are being developed and to limit the impact that mining could have developed in the last decades or so. When you consider what is being done presently, you realize that there are lots of initiatives, about 100 of them, that have been developed in the last few years. Some of them being national, the other one being international. Some of them are pushed by industry body, others by the public bodies, some of them also by NGOs. Some of them are promoting standards or labels, other not. And so it is important trying to take into account and to take benefit of all this work, but trying really to find a way to make them accessible together through a unique approach. Otherwise, it's quite difficult to make people discuss within each other if everyone has to push their own interest. So as you see, one of the big challenge will be to develop the possibility to push the best practice that could be useful for both the mining industry, but also for people living around and for the national aspect to promote the supply of material and get also agreement from the local communities for the development of mining in the surroundings. As we said in the beginning, the standardization could be a way to promote some standards or references that are shared by the several stakeholders. And for this, ISO, which is the International Organization for Standardization, is an independent non-governmental body, and the main objective of ISO is to promote and develop international standards that are pushing the best practices, especially environmental best practices or safety best practices, in order to make industry efficient and accepted and more positive and promoting the most positive image and efficiency of the process. So ISO push the concept of consensus building, meaning that all the stakeholders are gathered together on the same table, discussing the same references, and we try to build something acceptable for everybody, or at least for the large part of it, to be sure that not everyone will build his own standards and will not be able to discuss with the neighbor. Within ISO, there are several technical committees and also subcommittees. And so within ISO, there is a technical committee dealing with mining, TC82, and within TC82, there is a specific subcommittee dealing with the period of mine closure and reclamation management, meaning how to close properly a mine, how to manage the closure of existing mine, but also the mine that will be developed in the future, how to build them in order to reduce the impact on the long term. So this is very important in terms of environmental protection, but also of social aspect, because you have to manage the place that will be cleaned and secure in order to allow people to live safely in the surroundings. This is an initiative which is dedicated both to legacy mines, where you have to face something already existing from the past, but also the future mines, where you have to design them to reduce the impact on the environment. This committee have quite a large membership with big country that are active in terms of mining today: South Africa, Canada, Chile, Australia, China. So this is something quite important going on. The big challenge today that we could have to face in the next future is to discuss about enlargement from the mine closure concept to the responsible mining aspect. Both are connected because closure aspect is part of responsible mining, but only part because it's only faced the really end of the mine cycle life. So it's responsible mining could be a much more integrated approach to promote the best practice, not only at the end, but from the beginning, including the extraction phase up to the very end of the process. It is actually under discussion to enlarge the scope from the end of activity to the whole mine life cycle. And so the decision should be taken in the coming months to enlarge the scope, the aspect, and also the partnership to face this big objective and activity. In terms of technical challenges, the idea is to integrate much more wide panel from the very beginning to the very end, but also integrating some environmental, social, financial aspects to cover the whole process and the whole cycle of the mine. That is a very big challenge for sure, integrating also several kind of stakeholders. That is the objective of an international standard organization and project, and that will be in the future, I hope so, a big challenge to face in order to help the redevelopment of mining in Europe and elsewhere.
Thank you, Christoph, for this exciting insights in the work of your committee. We know about the importance of an international agreement regarding how mining should be carried out. The conciliation between the different groups of interests is very important and indispensable. Christoph, currently you're working on an ISO standard for mine closure. The idea is to define how a mining area should be left behind once extraction ends. Now you are aiming to extend this international standard. The committee would like to establish standards for the entire mining cycle. Which are the main aspects of this project?
Okay, so as I said, it covers two main dimensions. The first one is the timing aspect. So it means that to cover the whole mine life cycle from the design, how you build, how you build the mining method and the way to proceed. This also integrates the extraction period where you find and you apply the concept, and then up to the very end in terms of closure and maintenance to reduce the impact from your mine and optimize the fact from all the side. And the second dimension is the topic to be addressed. Topic should cover environmental aspect, but also social aspect, how to try to develop added value to every actors, not only mining industry, but also the people there on the national body, but also the financial and economic aspect, how to be sure that everybody can take benefit of this kind of activity. So it's a very large panel of topic, of people and of timing, and that's the objective of building something shared by everybody.
Okay, our economic environment is changing quickly. Important external factors have coming up in the last years. What learnings do you take out of the latest crisis with the war in Ukraine?
Yeah, as we said, I think the world is facing major transition that we experienced in the last few months and years. That world is also facing major crises and major uncertainties. And it is no more obvious than it used to be in the last years that when you need some raw material, you know that there will be some of them available in the market if you have money and a request. Now it's not anymore the same. We really face the problem to secure the supply of those materials and realize that when there is problem with some neighbors that are providing a lot of access to the material, there can be some break in the supply chain, and some of our factories have to stop because we don't have anymore this supply. So one of the big challenge will be to develop sovereignty of countries of Europe, and one of the possibility to make this possible is to reopen mines and to have secure access. Obviously, you have to build some partnership elsewhere, but you have also to consider the possibility to reopen activity in our countries to secure this supply to raw material. That's why responsible mining is one of the big challenges to make that possible.
Okay, the ISO standard is supposed to conciliate interests both of mining companies and the local population. What are the main challenges you are encountering when you are implementing this process, or when you are trying to implement this process?
Well, I think that the objective and the way to proceed from ISO is to integrate all kind of stakeholders, all of them having their own interests. I mean, it's not the same interest from a mining company compared to the local communities. So the idea is really to being able to build a consensus and not only adopting all the objective of one part and neglecting the other ones, but trying to build the best consensus in order to secure interest and potential added value for all of the actors. So that will be probably the biggest challenge, is to allow people to talk to each other and to try to find the best way to make this kind of activity acceptable and promote the best way to do it in a safe way.
Christoph, as you know, bauma is the main trade show for machine builders. What consequences would have an entire mining cycle standard for the mining equipment manufacturers?
Yeah, as I said, I think TC82 is a global mining technical committee, including several topics within. I mean, SC7 dealing with mine closure is one of the topics. There are other ones dealing with the building of the mining machinery of the future in terms of safety, in terms, for example, of autonomous machinery to enable people not to be in the most dangerous spot. So if we want to face the responsible mining, it also includes well-being of miners and the way to reduce the risk and to ease the process for them. So obviously, all the inputs of the outputs of the work being done in the initiative of TC82 working groups to push the best machinery for the future will be of great use to make it useful to reduce the impact on the people working within the mines. That's one of the examples where machinery could really promote a best practice in terms of responsible mining.
Christoph will be available right now in the chat, and thank you for being with us. Today we will have insights in an almost fully automated mine in Australia. Digitization and automation are two of the major trends in mining. Challenges like lack of skilled labor force, production efficiency and labor security can be faced. Michael Waller is Interoperability Manager at Roy Hill in Australia. Welcome, Michael. We're looking forward to your presentation.
Thanks, Christoph. So, as I said, Michael Waller, Manager of Interoperability at Roy Hill. So I'll be giving a little bit of talk around automation and interoperability in mining. A bit about Roy Hill. We're part of the Hancock Prospecting Group, a private company owned by Executive Chairman Ms. Gina Reinhardt. Our first ore on ship was 2015 as an iron ore company out of Western Australia. We basically are a large open cut mine. We move 360 million tonnes per annum. We crush and process 73 million tonnes per annum. And we ship 62 million tonnes per annum through our Port Hedland facility and have approval to get to 70 million tonnes per annum. So we also run all of this out of Perth, our capital city in Western Australia, 1,600 kilometres away in a remote operations centre. And we're actually investigating a whole bunch of new possibilities and opportunities to run through that facility as well. So a bit of the landscape for future of mining. We know we face some various opportunities and challenges in the future. That would include the ore bodies are getting a lot smaller, a lot more complex. And while iron ore is really high price at the moment, it's not going to be that way in the future. So we've got to look and be really effective around our costs. We also are going to be competing for a smaller pool of talent and labour, as Christoph mentioned at the introduction. And we want to be an employer of choice for this industry. So we want to really attract that talent into Roy Hill. And to do that, we've got to make sure we have really rewarding and flexible jobs that entice people to want to come and work into mining, particularly the younger generation. There's a lot of regulatory changes happening around the world and within Australia. And over that as well, there's now a different perception around automation. So if we looked at automation 5 years ago, it was seen as a fairly risky proposition. It was reasonably not so well known. Now it's actually considered more of the norm. We have lots of experience about it here in Western Australia, and the market of automation solutions has grown significantly. Outside of that, our license of operate expectations is growing. There's areas around emission targets for approval, the expectation of how we look after the land, the expectation how we look after water, how we manage energy. So all these areas are starting to play out in how we need to operate going forward. And as part of that, automation, connectivity and energy efficiency will play a really massive part around that. Automation, it increases safety, it takes our people out of harm's way, and it improves productivity. We don't have to have a machine that has to stand down while someone has a lunch break. It's going to operate the same way every single time. Its efficiency is a lot higher. And we also reduce the variability around human operators. So every single machine will operate in the same way and will be predictable and run as planned. Outside of that, the connectivity part is really where connected systems start to allow us to run this from anywhere. We can be running it from anywhere around the earth. And we start to empower our people with all the wonderful data we can get off these machines so that they can make more informed decisions, they can make better plans, and we can watch those plans be executed. And that really drives forward about coming up with a common language and a common messaging layer that really allows multiple solutions to work effectively together. And then if we talk about energy efficiency, at the end of the day, we need to work on how do we make sure we manage energy just like we manage safety, productivity and quality. It's essential that we manage every little bit of energy juice that comes into our mining operation, and we manage that load and demand just like any other planning cycle in mining. By using these connected systems and using this efficiency we get out of automation, that gives us a real power to be able to manage energy effectively on site. So our first foray into autonomous operations for Roy Hill was around, we started with autonomous drilling. We selected a OEM agnostic platform with our partners Flanders. So we use a Flanders system on our 12 Atlas Copco Pit Vipers. And these were a really successful project. We met all our targets and exceeded them. So we had working hours greater than 21 hours, and we were getting drilled meters increased by about 14%, which was a real bonus from what we wanted to run as a project above and the safety cases we got of moving to autonomy. But more than that, by removing the human operators, we got the drilling variability reduced, and that gave us increased visibility of our data. So we were able to get better data off what was happening within our drill holes, and by that apply it to our blasting processes, and therefore get better blasting patterns, which then further feeds up the chain within mining. So a small improvement at one end of the supply chain suddenly makes massive improvements all the way up through our operations. And we ran all this out of our remote operations center, included moving all of our drillers off the drill rigs and retrain them, reskill them, and give them different careers, starting as drill controllers back in our Perth operations. And that is a good example where autonomy isn't always about reduction in labour. It's actually about reskilling and retraining and providing these flexible and rewarding career opportunities within an organisation. So we're now moving on to our next really big project, which is our autonomous haulage project. And again, this is probably the biggest OEM agnostic haulage project in the world. And we're partnering for success with Epiroc and ASI Mining. And it is a really capable and efficient solution that's cost effective that we can apply it across all of our fleet, because we have a mixed fleet, and potentially we're bringing in other types of truck types into our operation. So essentially, we're able to run an autonomous solution where we can select whatever's the best mining equipment to run at that time. So at the moment, we have it running across Caterpillar 793Fs and Hitachi EH5000 dump trucks. And we have currently 10 operating in a production environment 24/7. So it's running to plan, checking its viability, make sure everything can work before we roll it around the rest of the fleet. And essentially by the end, we'll have 100 haul trucks running under this solution. So Roy Hill's goal isn't just around an autonomous drill and an autonomous truck. Our role is to set up a autonomous mining ecosystem. And it's really important that this ecosystem exists, because what we want to do is essentially set up a solution where we can buy this from multiple different vendors, bring in these solutions that are best tailored to our environment, and have them operate successfully together. That means they need to be able to share information, they need to be able to share maps, they need to be able to communicate with each other effectively, they need to be able to deal with an emergency situation, they need to be able to operate independently. So we want to establish an environment that allows that to succeed, because that will actually give us the most chance of meeting all those future challenges that we discussed earlier in this session. And that would mean that a water cart coming in, it can do its own operation of managing water effectively on site, but still knows how, for instance, to operate with a haul truck and not get in its way and not cause a production cycle issue where we want the ore held up because the water cart isn't going fast enough, for example. So this is where really then the interoperability question comes in, and why Roy Hill is such a proud supporter of it. We see interoperability and standards as being the way for creating that environment to succeed. And that's about setting messaging standards, coming up with this common language, and setting it up in a way that doesn't inhibit innovation, and it allows suppliers to produce whatever they want to produce as a platform. But when they operate in these environments, they know how to operate in sync, and they know how to cooperate with each other. So we're working very closely with areas like VDMA around their OPCUA companion specifications, the ISO standards in this space. We've also just joined the MEOS consortium with Rio Tinto and Oz Minerals, looking again at going through all the various use cases around interoperability to see if we can make that successful. We've also in Australia done a lot of work with EDI Test Labs, Mets Ignited and Ozmine around setting up interoperability challenges and getting the industry really behind it, including suppliers and other mining companies. And essentially what's in it for Roy Hill, if we get this right, It'll give us the ability to accelerate automation. We can grow the automation market, and we're also able to leverage other industries. As other industries grow and come up with these standards, they can be incorporated within mining. So mining doesn't have to be the only one coming up with these automation approaches. We can create shared services like better maps, better data, single use of wireless networks, single use of GPS networks, and the data becomes accessible to all. So the data will empower all solutions, and it allows us to empower our people. And it'll also allow us to look at other sort of options like smaller trucks, electrification, and areas like moving into automation on public roads, and how does the public roads intersect with the mining, with our mining operations. So it's all really very exciting where we're going along these lines, and it's really important that we work really closely with the industry about making this successful.
Thank you, Michael. Thank you very much for this really impressive presentation. A fully autonomous mine is possible in the near future. The automation of processes brings along a lot of advantages. Michael, your company Roy Hill's vision is to have its existing and new mining operations fully autonomous. This is a quite challenging goal. What factors are you pushing in this direction?
Yeah, thanks, Christoph. It's a very important question. Look, not outside of obviously with automation, it's all about keeping our people safe. Automation is proven to be very effective at reducing the amount of incidents in the mining organisation, particularly on site, particularly between heavy vehicle to heavy vehicle and heavy vehicle, light vehicle. But more importantly, it's all about enabling us to move our people out of being in the pit, being away from their families, working in a FIFO situation, to more effective jobs and more rewarding jobs over time. And that's, again, moving us back to making Roy Hill an employer of choice. And being really attractive to the next generation to come and work into mining, and have those better roles that we want to provide our people with. But outside of that as well, we can see that the mining industry is already moving heavily towards automation, and automation will give us a lot of opportunities to mine differently in the future and take advantage of the ore bodies that we are provided, because you only get one chance at mining them effectively. So automation, with its predictability, its lack of variability, allows us to be very precise about how we go and mine in the future and get the most out of the ore body that we're given.
Okay, Michael, automation as well is supposed to contribute significantly to sustainability of the mining industry. Under what aspects do you see this contribution?
Thanks, Christoph. Yes, so I guess it comes down to that same scenario, really, that because automation will do as we ask it to do, it will do the same, it will execute to the plan we give it. It means we can be much more effective at managing its impact on the environment. So if we automate a water cart, we know how it's going to go and manage the water. It's going to put the water in the right space. It's going to water to the right amount. It's not going to overwater. It's not going to underwater. So in that aspect, the automation can be used to make sure we're really effective on how we actually interact with our environment. And an example would be, again, around energy efficiency. If we need to manage energy and be really clear about how we're managing our load and demand, well, we can start or stop the automation. The automation will drive exactly how we would like it to drive to maximize the amount of energy it is using. It might, if we've got too much energy being consumed on site, we were able to slow down the machines to meet our plans, or vice versa. If everything's going really well, then we can speed back up, and we can give that commands to the whole fleet, and the fleet will, instantaneously that the command is given, will start to follow it. So the reality is automation gives us the ability to really deal with changes that happen on the mine site in short interval control, so on the hour or on the minute as they're going about, and make decisions that allow us to maximize not only our productivity and safety, but how we interact with our environment and areas like energy going forward.
Okay. Michael, Roy Hill is a very active member of the Open Platform Committee of VDMA. You're working on companion specifications for mining operations. What are your expectations regarding OPC UA?
Yeah, so I guess with Roy Hill, we've always gone on the basis if the industry wins, we win. We're not big enough necessarily to influence the whole industry by ourselves. So we need to look for partners and existing organizations that are already have connectivity out to a wider audience, are already looking into aspects of areas like standards and setting setting ways of working going forward, particularly around interoperability. So as part of our, I guess, move into interoperability, we did a bit of a scan and found out who was doing work in different places. And that's where the conversation with VDMA came up as part of our conversations with Mets Ignited. And what it's allowed us to do is actually get to a win-win situation for both sides, because VDMA are very skilled at obviously creating standards, creating standard messaging layers, using the OPC-UA specifications. But what they needed was help to apply that into a mining examples and have the use cases that the industry needs to solve for. So for us, it was a great way to combine up the two powers of the people, the organizations that we, both ourselves and VDMA. We have plenty of good ideas about it, knowing exactly what we need to support that ecosystem that we showed on the slide. And VDMA have the expertise about how to turn that into a specification that hopefully over time will become the standard that the industry adopts and suppliers start to utilize, and therefore accelerate their solutions and make it easier for Roy Hill to implement them, because ultimately that's what we want to see, an ease of us to be able to use them and apply them very quickly into mining environments.
Michael, thank you very much for this really exciting insights in your mining company. Really a pleasure to have you with us. Michael will answer your questions in the comment section of LinkedIn, and thank you for staying with us. How can machines communicate with each other in a larger network? Each mining site is a network, so creating interoperability is one of the main challenges that ABB is facing with their mining customers. Eduardo Lima from ABB is today with us. Eduardo, it's your turn.
Thank you, Christoph. Today I present the interoperability standards in mining short interval control. So how you can do a practical approach that will bring interoperability in terms of mine operation. So one of the cases that I bring here is with the guideline mining group that's looking after different levels of digital maturity in short interval control. And then how we together with them use these interoperability standards to come in that direction. So the first one, we talk about level 3 that is integrated. So how you can use OPC-UA to enable that. So more and more we have different devices at the machines that want to bring that information to the mine control room. So through interoperability standards in one of our projects, we are working with Goldfields ETP in Australia in the RDI test lab. So that's part of the university, where you use the integration of these onboard devices and you use OPC-UA to make that open, reliable, and the connectivity. So in that sense, it's very important, the collaboration, and that OPC-UA companion spec for mobile machines is very important in that interoperability. So that's one of the cases that we bring here. A second case is level 4 that we talk about decision support. So decision support, we have been collaborating with Amira in that case in Australia, so that we have interoperability enabled for natural resource project. In that project, we want to integrate the systems as well that's running on the top of the machines. And what that means is you have mining planning tools, you have execution tools, scheduling, and the equipment. So what you decide what the equipment do next, it relies a lot about your possibilities of communicate between them. Here we are using the ISO 95 standard when you say that basically you are modeling the operation of the mine. And by modeling that, we can have a better integration between machines and systems as well. So again, we show different, let's say, vendors that, and as well mine companies that we have been working that project in Australia. So we have the ERDI test lab. So in the ERDI test lab, we can see, if you are in Perth and you visit the lab, you can see that in action. So how we have been using that standard in the level 4. The next, we can talk about semi-automated. So one of the goals of short interval control as well, once you have integrated the data, have integrated the scheduling, is how can I automate part of the work that's done by the mine controllers? And again, the use of the operations modeling by ISO 95 allows a generic way because each mine is unique. So when you're looking for short interval control and how you want to do the scheduling there, it's very important that you can have a way to adapt that through modeling, in a modeling that is open to everyone at the mining industry to use. So here I show that the glue of scheduling comes from the life of mine, extraction plan, and then comes to the control of machines, okay, where the machine goes and the activity control. In this case, we have collaborated with the Sustainable Intelligent Mining System that was funded by Horizon 2020 in Europe. So during 2 years, we have worked with different vendors again, with mine operators, to develop application that's based on ISO 95 standard and B2MML, and as well using scheduling algorithms, heuristic algorithms to support that. The next example here is the level 6, that would be highly automated. So what we're looking in the short interval control, we talked about integration of the data, talk about decision support, that they have information that the mine controller can not look only what the machine is doing, but services, maintenance, how is the minerals processing running. So here you bring the automation ML. With automation ML, we are not anymore about operations modeling, but material flow modeling. In a highly automated with autonomous machines, connecting mobile and fixed equipment. So it's very important that you move from just looking to what the task of the machine, but also look at the overall value chain. So the material that is moving from the mine, that goes through material handling and minerals processing. So we believe here that the way that we are controlling is not anymore about maximum production, but maximum productivity, so that you can really rely on energy efficiency, for example. So, and here it's not so easy to visualize that here, but basically we are using automation ML to map the material flow, and then afterwards you have a framework that you can use analytics, machine learning, discrete event simulation, and really opens not only for new sites with the latest technology, but as well that you connect legacy systems, legacy softwares to make use of that through automation ML. To finish my presentation here, so through these different aspects, we have as well new standards to come for the future of mining. And here again, we talk about collaboration. So in that case, we have the Sustainable Underground Mining project that's happening right now in Sweden at the LKAB. In that case, that mine is going for great depth, I mean, more than 2,000 meters. So how do you keep that production in a safest way possible, is still that that production system can be autonomous and that mine is still profitable? In that case, new standards in different areas are being looked after when you talk about automation, electrification, and so on. So many things that you saw about short interval control now, we are looking after together with the customer, OPC-UA, ISO modeling that we use for modeling of operations, the same with automation ML for material flow optimization. Because in a mine like that, if you want to have autonomous operation, that is a key part of that. So here I went through some of that case. So of course, I'll be happy to answer some questions.
Okay, Eduardo, thank you very much for this really great insights into the mining world of ABB. Enabling the communication between machines in a network like a mine is quite challenging. ABB is one of the companies working on this. We have one of the experts today with us, Eduardo Lima. Eduardo, as we talked a few days ago, ABB is very active in mining in the field of interoperability. Your job is taking you to close cooperation with mining companies. Which are the core challenges you observe when it comes to the implementation of interoperability in mining?
Thank you for the question, Christopher. One of the main challenges that you see is a deadlock, because if you want to implement a standard, if you want to do standardization, you need to the users practicing using that standard. And make use of that standard as well requires that the vendors adopt that. So how do you do that if the vendors are not adopting, that you have the end user practicing using that? So that deadlock we try to, let's say, overcome, as I have presented, through collaboration. So the examples in the ERDI test lab in Perth, or the SUM project for LKB, the SIMS project with Boliden. Yes, you are really going together with the mine operator because they should push the vendors together, that you can practice that standards, learn of that. We can see what works, what doesn't work. So I'd say that a key message for interoperability is collaboration. So one of the reasons to be with bauma, with VDMA, to work with OPC-UA standards, the same with ISO 95. So all these specs are very important to the industry, and they should really work together.
Yeah. This is a point I would like to come to, because your company has been participating very actively in the VDMA committee on OPC-UA. My colleagues are working with several member companies on companion specifications for the mining industry. What is pushing you towards an open platform communication?
OPC-UA is a cornerstone at ABB as an automation company. So we are looking at not only at the mine, as we discussed that, but in minerals processing, this is already a reality. So how do you communicate control systems with historians? More and more you have IoT devices that should support OPC-UA. Even the PLCs and the control level as well do the same. So that's why it's very important to us, and that's why ABBs participate actively in OPC-UA. From my side in mining even more, that with the connectivity that's being open and the 5G coming to the mine operations, more and more you have IoT devices that requires a reliable communication, an open communication, and the most important, needs to be secure. So that cybersecurity is a key thing, and the OPC-UA provides that. So that's one of the reasons, or many reasons, why ABB is collaborating. So we have power consumption management that we just started, collaborate on that. That's a key message for ABB, our electric mine. So our e-mine solution relies on that. So we have battery chargers. That's a fixed equipment that's communicated with a mobile equipment that's coming to charge. So OPC-UA is part of that. I demonstrated in the short interval control. So have new device that you want to communicate with the machine, just not get the date of payload, but what's the context of that payload. And then OPC-UA data modeling allow that, so that's a very important part.
Eduardo, let's talk briefly about international standards. In international standards, interoperability is described by the ISA 95. Can you give us an example of how you implemented this standard in mining?
Yes, that has been a long way that ABB has working the ISA 95. As you know, ISA 95 is majority used in manufacturing industry. So that's really the concept. Operation modeling is there. The research like equipment, personnel, and equipment is used. So we have been working since 2014 that you bring that ISA 95 standard. Companies like BHP has been pushing that. So that together with other mine vendors as well, together with mine operators, we have using the ISA 95 to do that operation modeling. But it's not only about to do modeling standardization. So which benefit that brings? And some of the benefits that brings is you can connect different systems that before were not interoperable. So you should build interfaces between mine planning, mine execution, inventory management. So in this project in Australia, together with the RDI test lab, what we are doing that, we have a message bus so that the master data can be shared between different applications so that you don't have the need to configure one by one manually. Also have the communication between these solutions, these softwares that is enabled by the ISA 95 in the way that you do the messaging between MML. So that's very important to us. We have been really pushing ISA 95. In 2018, a new specification was coming more mining-related, let's say, functionalities, like event-centric messages. That is very important, for example, in Fleet Manager. So we are really pushing an approach that's very practical. So we are using that together with the mine operators, with different suppliers, with universities to make these standards really coming through to the industry. So walking the talk.
Okay. Eduardo, thank you very much. Really impressive insights into the mining world of ABB. Thank you very much for being with us. Thanks for joining this bauma talk on mining. A pleasure to have you with us. Hopefully you will subscribe for the next bauma talk, and then we're looking forward to meeting you in Munich in October of this year. Bye-bye.